So this is the first of a few videos to review our Cal-based physics material. And first I'm just going to go through electrostatics. So the first thing that you need to know with electrostatics right here, y'all can't see that, but I can move that for you. The first thing you need to know is charge and Coulomb's law. You need to know that there are two charges, a positive and a negative, and you need to know that charge is always conserved. We can't create it, we can't destroy it. It can move, but it can't be created or destroyed. There are a few different methods to charge an object. The first is through friction, and that would be like rubbing the balloon against your hair. The balloon will develop a positive charge, and your hair will develop a negative charge. Actually, I'd have to look up which one, the properties of each material. But one of them will develop a positive charge, and one will develop a negative charge because the electrons will move from one object to the other, and you'll be left with different charges there. To charge by contact or conduction, actually, let me do that one first. There's charging by induction. That's polarization. All right, charging by contact, before we get into that, and I know this isn't on that screen, is when you have a positively charged object and a neutral object, and you touch them together, and each object ends up with half of the positive charge. So you actually transfer charge by bringing two things into contact with each other. And then they end up having the same charge. So if you've charged something by contact, not through friction like rubbing, but through a neutral object and a charged object coming together, once they are separated, they will repel each other because they should have the same charge. Then there's charging by induction. Charging by induction, you have a neutral object. You bring a charged object near it, but do not touch it. You ground the neutral object, so all of the charges that are the same as the rod that was brought near it will run off here. In this case, it was electrons. Then you remove the ground wire, and then you remove the rod. And in that case, you are left with a charged object that has the opposite charge of the charge that was brought near it. So this was a negative rod that was brought near it, and the neutral object ended up becoming positively charged. And I also want you to understand polarization. Polarization is not developing a charge on an object, but separation of charge within an object. So if we have a balloon that we've charged through friction, and we place it on a wall, the wall is neutral, but what will happen is all of the negative charge will line up closer to the balloon, and all the positive charge will line up farther away from the balloon. And so you will get this polarizing effect on the wall, which is still neutral. And it will attract, because of Coulomb's law and the fact that you've got that 1 over r squared relationship, which I'm about to talk about in just a minute. Because this force has less distance, it is a greater force than the force of repulsion between the positive charges. And so the net force will be attractive. Those quizzes are good, by the way, if you do them. All right, Coulomb's law. Coulomb's law says that the force of electricity between two charged particles is equal to K times the charge of the first object times the charge of the second object divided by the distance between them squared. You're just going to need to plug that one in. K is given to you on your formula sheet. It's 9 times 10 to the 9th Newton meter squared per Coulomb squared. What I really want you to understand is that this is a vector. It is a force. So what I do is I use Coulomb's law to determine the magnitude of the electric force, but I don't generally put positives and negatives on these charges. Instead, I look at the picture and draw a free body diagram with the arrows going the correct directions based on whether the force of electricity is attractive or repulsive between two charges. Remember that like charges will repel each other and unlike charges will attract each other. We are going to use this relationship a little bit later when we get into stuff about electric fields. But so this, it's on your formula sheet as well, but that K is actually 1 over 4 pi E naught, and that E naught is the permittivity of free space. Those are variables which are provided on the formula sheet, but I do want you to understand that that is what that K stands for. So you can relate the K and the E naught. There's a simple relationship there. And I think I'm going to stop there, and I'm going to come back to electric field and electric potential, partially because I want to make sure that this screenshot is working as it should. Make sure there's nothing